Hello students, welcome to Tuteetute. So we have given some previous year questions and important questions from the other subject. So this is power plant engineering. So in this session we'll understand this 500 questions. Okay, so in that some questions we'll be understanding from the power plant engineering. Okay, so some of the questions related to the hydroelectric power station and thermal power station, and similarly so different energy conversion methods, all these type of questions will be coming. Okay, but in this session we will be learning from the thermal power station. Okay, so let's see the first question. In steam power plant, which of the following components needs more maintenance? Okay, so this is one of the important question. We need to understand this question. Okay, so directly by seeing the options: condenser, boiler, turbine, coal carrying system. Okay, so what are these things? So if you are belonging to mechanical engineering or electronics, otherwise civil, okay, so you will be seeing this one for the first time. Okay, otherwise if you are from the electrical, you will be knowing these components before only. So anyhow, if you need to understand the concept, so you need to see about this diagram. Okay, so this schematic diagram of thermal power station or steam power station we need. Okay, so this is the coal input we will be getting. This is the ash, whatever boiler is there, from the boiler ash output will be coming, so that will be going to the other side. Okay, we have to dump that ash. Okay, so this is the boiler one. Okay, so what boiler will do, so it will be burning, okay, from the coal. Okay, so it will be adding to the air and there will be burnt inside, and water will be converting as the steam. Okay, see, from somehow we will be taking, I am not explaining entire thing. Okay, so water we will be taking like this inside, and hot air also we are taking inside, will burn inside. Okay, so this one, so that water will be converting inside the boiler, water will be converting into steam. Okay, so here steam will be coming like this. Okay, so that steam we have to send to the turbine, so then condenser we have to send. Okay, so like that it has to be. So and again it's a complete feedback process will be continuing. Okay, so that is the entire one. Okay, so what they are asking, so they are asking about, so which part need more, okay, so maintenance. Okay, condenser, boiler, turbine, coal carrying system. Okay, so let's see what are those things. So coal carrying system means here conveyor belts will be there. Okay, so conveyor belts will be there. So that conveyor belts are mechanical components here. Okay, so they have only fixed work. Okay, so that is the first one. Okay, so next turbine they have given. Okay, so turbine. So turbine also one of the important component in the thermal power plant. Okay, so next one is condenser. What is the work of this condenser? So this condenser, so will be, so this steam will be coming, right, like used steam, otherwise exhaust steam will be coming from the turbine. So that condenser will be converting that exhaust steam into hot water. Okay, so it will act like a conversion of this exhaust steam into hot water. Okay, so like that it will be working. Okay, so what turbine will do, it will convert the steam, hot pressurized steam into electrical energy. Okay, so electrical energy by using a common shaft. There will be some coupling between the generator and turbine, so because of that there will be electrical energy production. Okay, so that's the work of this one. Okay, so which system here is having more burden, that we have to understand. Okay, so here we have to confirm this condenser and similarly conveyor belts and coal handling system. Okay, so these are having fixed works, but so there is no energy conversion is happening here. Okay, so energy conversion is happening only at the turbine area, okay, and boiler area. Okay, here what is happening, the water we are converting as a steam here. Okay, so here more losses will be happening here. Okay, so more losses will be happening at the boiler area. That's why, so the boiler area need to be having more maintenance. Okay, so more maintenance. Okay, so this is the answer. Directly by seeing this question only we can answer, but we need to understand as this 500 questions why we are giving. So whoever wants to revise the concepts, okay, so these 500 questions will be useful for them. That's why we will definitely give some explanations. Okay, so if anybody knows these type of explanations before, you can forward and go to the next question immediately. Okay, so anyhow, answer for the first question is, okay, so boiler. Okay, it need more maintenance. Okay, if you need the order also, after the boiler turbine required more maintenance. Okay, so after the boiler turbine is the next maintenance required. Okay, so after that condenser required, after that coal carrying system or coal handling system. Okay, so this is the order. Okay, so next the pH value of the water used in boiler is, okay, so what they have given the pH value, okay, so the pH value of water which is used in the boiler, okay, so here we need to understand, just from the schematic we can get everything, okay, see, from the river we are taking the water, okay, so before that there is certain block here. What is this one? Water treatment chamber. What we are doing here means we are demineralizing the water, okay, so DM water plant it is, okay, so DM water plant. What is this DM water plant? We have to demineralize that water. There are no minerals required for that, because whenever minerals enter into this boiler, okay, so there will be some conversion, energy conversion may not be proper, and there will be more losses coming, and the chambers of boiler may be getting some rust, otherwise maybe corrode, or some reasons will be there, okay, so that's why, so minerals should not be entering into the boiler, okay, so that's why which kind of water we have to send? So whichever water and whichever pH value is slightly greater than 7, that kind of water we have to send, okay, so that's a simple answer. So slightly greater than 7, okay, so this answer will be the correct one, okay, so no need of more explanation for this one, okay. So next one, for the flue gas flow, okay, so tick the correct sequence. Flue gas flow they are asking, okay, what is this flue gases? So let's consider boiler, some elements they have mentioned there. So flue gases, okay, so flue gases, what are these flue gases? First, see, if this is a boiler, into the boiler we are sending the coal, okay, so coal we are sending, and similarly water we are sending, okay, so water. So if you send hot water, it will be easy to burn, right, easy to convert as the steam. That's why we will send hot water. Instead of sending cool water, we have to send hot water, okay. So and similarly for the coal burning process, we need air. We need air. So if hot air if you send, it will be more easy for the combustion process. That's why we will be sending hot air, okay, so hot air. So this is the process, okay, so we need to send this water, and this water will be coming like a steam, okay, so steam. So what is happening? These are inputs and this is the output. What is unwanted output we will be having? So whenever you burn the coal, whenever combustion happens, definitely there will be some ash content will be coming. Yes or no? Ash will be coming, right, okay. So some of the ash will be having more weight, some of the ash will be having less weight, okay. So whichever is having more weight, it will be called as bottom ash, okay. So bottom ash, okay. So whichever ash is having more weight, less weight, it has to fly, right, okay. So if it is having less weight, so it will be flying, right, okay. So that we have to call as flue, or okay, so flying ash it will be, okay. So that means so it will be having, so this is bottom ash, and that will be fly ash, okay, so fly ash, okay. So in this fly ash there will be flue gases, okay. So in this fly ash there will be flue gases, okay. So what are these flue gases? These are poisonous gases and dangerous gases, but these are having very high temperature. Understanding? So these are having a very high temperature, but these are very dangerous. You cannot send these things directly to the atmospheric area, okay. So that means from the chimney, okay, so whenever you see the thermal power station, there will be outside, so 1 or 2 chimneys will be coming, right, okay. So there will be ash continuously coming. What is that ash? That is bottom ash or fly ash? That is fly ash, which generally should be having these flue gases, but we should not send these flue gases into the outside, okay. So that's the main reason. So because these are dangerous, okay. So what they are asking, for the flue gases flow, okay, so flue gases flow, tick the correct order, okay. So anyway they will be starting from the boiler only, okay, so boiler only. After the boiler, where they will go, that's what they are asking. So for this just schematic only we have to see, okay. See, these flue gases will be coming like this. So order is after boiler superheater, after superheater economizer, after economizer air preheater, after that so induced draught fan, after that chimney. This is the order, okay. So we have to remember all these things, okay. So first thing is boiler, okay. So next superheater, okay, superheater, okay. So next economizer, Okay, so economizer. Okay, so next air preheater. Okay, so just consider air preheater. Okay, so next induced draught fan. Okay, so next chimney. Okay, so chimney. So this is the order. Okay, so they may have not given some of the elements in between. Okay, but we need to see. Okay, so boiler. After that, directly ID fan is there here. Okay, so before that, economizer should be there, right? Air preheater should be there. Okay, this option is wrong. Okay, so boiler, air preheater, economizer, it's a reverse. Okay, so this is also wrong. Okay, so boiler, economizer, air preheater, ID fan, chimney. Okay, so this is the order. So they have given 5 elements here, but here you see boiler, superheater, economizer, air preheater, induced draught fan, and chimney. Okay, so this is the complete order. Sometimes they may give only these 3. Okay, sometimes they may give only these 3. Okay, like that, but you have to remember the order. So you may get doubt why we are sending these flue gases through all these elements, because so here superheater, what it is doing, we are sending the steam into the superheater. So we will increase the heat of that steam, temperature of that steam by sending these flue gases. So if this is the pipe, okay, so on the pipe we will send the flue gases into this superheater. So this steam temperature will be little bit increased. Okay, so similarly we are taking the water inside, we have to send hot water to the inside, right? That's why what we are doing, these flue gases, similarly in this pipe, okay, so water will be coming like this, flue gases will send like this. Okay, so definitely these are hot gases, that's why, so definitely this water will get heated. Okay, similarly hot air also we have to send inside. We are using this unwanted quantities also as some feedback. Okay, so we are using those things as our feedback. Okay, and then we have to send that outside. Okay, so before that there should be another element. Okay, so another element should be required. So what is that means? Electrostatic precipitator. Okay, so here we should have electrostatic precipitator. Okay, so why means these flue gases directly we cannot send outside, we need to collect those things. Okay, we need to collect this unwanted, otherwise dangerous gases, then only smoke we have to send outside. Okay, so that's why this electrostatic precipitator is must required, but in this diagram it's not mentioned. Okay, so anyway, so after this air preheater we will be having electrostatic precipitator also. Okay, sometimes they may give this option also. Okay, this is one of the very important component. So recently, okay, so in Telangana, so Yadadri power plant, you know, okay, so they have so rearranged some of the things because of this electrostatic precipitator only, because so environmental issues. Okay, you know, Green Tribunal, they have questioned something, so they want to change. This is very big plant, so you need to change some things related to this. So collection of elements, collection of flue gases, and we should not send these all the elements outside, we need to collect even more perfection. Okay, so that's why electrostatic precipitator, so we should definitely use here. Okay, so that's what the question. Answer for this question is boiler, so a superheater, economizer, air preheater, so after that electrostatic precipitator, and induced draught fan, and chimney. This is the order. After that atmosphere only. Okay, so next question, hydrogen cooling employed in large thermal power plant alternator which increases the insulation life, decreases the insulation life, does not affect the insulation life, none of the above. Okay, so what they have given, hydrogen cooling employed in large thermal power plant alternator. Okay, so large power plant it is, hydrogen cooling we are using near the boiler. Okay, so why we are using, actually boiler will be having very less efficiency, so there will be continuous energy so wasting. Okay, that means heat energy wasting there. So what we have to do, we need to provide certain cooling for this one. Okay, so that's why, so it will increase the insulation life, boiler insulation life. Okay, so that's what the answer directly. Okay, no need of more explanation. So the efficiency of electrostatic precipitators will be of the order. Okay, see, they are asking about electrostatic precipitator. These are all very important questions. Okay, so that's why I have taken here. So see, I will be taking the questions which are very important and which will give us more conceptual questions, and we need to think about those questions. Okay, like that type of questions we will be answering. Okay, so electrostatic precipitator, what's the work of this electrostatic precipitator? So flue gases will be coming. Okay, so flue gases will be coming, so that flue gases it has to collect and only smoke. Okay, so smoke, Okay, only smoke it has to send outside. So this is induced draught fan. Okay, so induced draught fan. So after that, so there will be chimney. Okay, so chimney. So from this one, so the smoke will be going like this out into the atmosphere like that. Okay, see, flue gases it has to collect, right? That is the work of this one. How much efficient it has to collect. So because we are sending those things in the atmosphere, right? Okay, so if this is not working properly, so all these flue gases will be entering into the atmosphere, then that area people, whoever is having near to the thermal power plant, so generally thermal power plant will be constructed near to the center, okay, cities, near to the cities or near to the load centers, wherever load is required or wherever higher loads are required, that kind of areas will be constructing. Okay, so you can observe, okay, so recent our Yadadri power plant, okay, so where it is, you can observe that area. So already some people are roaming there and there are certain villages will be there, so all these things will be there. Even in the Rayalaseema also, okay, so and even in the Costa area also, okay, near to Vijayawada, so we have certain power plants, okay, where they are near to the cities, okay, so that's when are near to some town. Okay, so that's why these thermal power stations they have to construct near to the load centers or near to the transporting area only. Okay, so that's why anyhow coal has to come every time, right, through the lorries, otherwise through the trains. Okay, so it has to come. So that's why, so there should be some connectivity also. That's why we will definitely construct the thermal power plant near to the load centers, near to the human beings only it will be. Okay, so if you send this outside means definitely it has to be it will be a very big problem. That's why whoever near to the thermal power plants, okay, so if they release that, they will be getting skin diseases, lungs diseases. Okay, so all this kind of so unwanted diseases, who other world will not be experience that kind of problems. Okay, so anyhow, so should not send all these flue gases outside. That's why efficiency of this one should be near to 100%. Okay, so near to 100%, then only we have to allow that power plant for the construction. Okay, so whenever permission is given, so they will be coming for the checking, right? Okay, so green tribunal they will definitely come and check. Okay, so every 2 years once there will be some checking also will be there. Okay, so inspection we will be calling. Okay, so anyhow answer for this question is 99.6%. okay, so the next question, without electrostatic precipitators. Okay, so again electrostatic precipitators they are asking. So we know already in previous question also we have seen, if we don't have this electrostatic precipitator, what we have to do? That's what they are asking. Okay, see the question, without electrostatic precipitators, so see the options. Okay, ID fan rating should be increased, economizer rating should be increased, chimney height should be reduced, none of the above. Okay, so let's see this option first. Okay, so what is this option? Chimney height should be reduced. Okay, so chimney height should be reduced. If you decrease the chimney height, what will be happening? So the entire nearby areas will be having, see, if that is more height, then if with the why we are giving this induced draught fan forcefully. Okay, so like it will be sending all the smoke with a certain height, not only this chimney height, okay, even more height it will be sending. Okay, so because from that height it won't be falling, so because certain height it has reached, so it will be flying away. That's what the intention. Okay, so that's why induced draught fan is present here. Okay, so anyhow if you decrease this chimney height, what will be happening? It will be spreading here only. Okay, so in this area only it will be easily spreading. Okay, so then automatically so more damage will be happening. Okay, so that means if you don't use electrostatic precipitators, otherwise if you use electrostatic precipitator also, chimney height should not be decreased. Okay, it has to be more, or it has to be, so smoke has to be go outside, so even more height it has to reach. Okay, so that's what the analysis. Let's see. Okay, economizer rating should be increased. What is this economizer? Why economizer is required here? So economizer does not related to this electrostatic precipitator. Okay, so nothing is related to this thing. Okay, so then other option we have to observe. Okay, so what is the ID fan rating should be increased. ID fan rating should be increased. what's this ID fan? Okay, so whenever ID fan is here, so if this rating is increased means the force on this one, otherwise whatever output is coming for this one, definitely so it will be increased. That means with more force they will be going away from the chimney. Okay, so that means they will be reaching certain height easily, so then they will be flying away. That's what the intention. Okay, so that's why these dangerous gases should not be reaching. Okay, if you don't have this electrostatic precipitator here, okay, so if you don't have electrostatic precipitator here, then these all flue gases must be flown away. Okay, so with a great heights. Okay, so that's why, so it should, option A should be correct answer for this one. Okay, so next one, in thermal power plants the condenser used is of, okay, condenser they are asking. So what is this condenser? Okay, so condenser use already we have discussed. We are using that one for the conversion of steam into the hot water. Okay, because exhaust steam we will be calling. Why we are calling it as the exhaust steam means, see, steam will be coming from the boiler. Okay, so this is the steam, so it has to go to the superheater. Then so valve we have why this valve is there? Because for the control. Okay, so for the input control, so for the turbine we are sending the steam, right? So that steam which should have some control, that's why, so there should be some valve required definitely. Okay, so after that, so we have used that steam. After using the steam, okay, so the turbine will rotate and that steam will come out like this. Okay, so that means that steam is called exhaust steam or used steam. Okay, so you may get doubt, why this used steam? Can we use this steam again or not? So this used steam we can directly use here in the boilers, but what happened, so this used steam will be having some expansions, otherwise some bubbles will be coming. So all this we cannot directly use, because previously pressure is there, previously high temperature is there. Once it has used, it may drop down. Understanding? So this steam directly we cannot use again. That's why what we have to do, we have to convert this into hot water. Okay, so condensated extraction pump is there. Okay, so using this pump, that hot water we have to take. Okay, so that's what so what is this condenser we doing here? It is converting this exhaust steam into the hot water. Okay, so hot water. So what then which kind of condenser is required here? That's what they are asking. So to convert better, okay, so in the power plants also you will be seeing. Okay, so if you see any power plant, so one big chimney will be like this. Okay, so like this. Before that, okay, so there will be having some cooling tower like this. Yes or no? Cooling tower. So thermal power plant means definitely we will be seeing this cooling towers only. Okay, so if required, more than this also will be having. Why this cooling tower means, this condenser continuously changing this steam into hot water. Okay, so steam into hot water it will be changing. So that means some water we have to add. Okay, so some water we have to add to this one. That's why you see from the cooling tower some water will be sending like this, and again this water is coming. Where this water is coming? From the river we will be taking, otherwise some pond. Okay, so any water availability so required, so cool water we have to take like this, and it has to mix with the steam, then hot water will be coming. Okay, so that's what the idea. Okay, so anyhow for the better conversion, okay, so conversion of this water, so what we have to do, we need to use this surface type of, okay, so surface type of condenser. Okay, surface type of condenser we have to use. Okay, so next question. So the purpose of spray pond in thermal power plant is, okay, so spray pond they are asking. What is this spray pond? Spray pond means, so generally here we have given in this diagram as a river. Okay, so sometimes river may not be available. Just see like so our RTPP, okay, so Rayalaseema Thermal Power Plant is there. Okay, so near to Rayalaseema Thermal Power Plant, there is no river availability. Okay, so no water availability. So but what we are doing here, so but water requirement needed here. That's why what we have to do, so there is a requirement of some pond. Okay, pond. To this pond, so through the canal we will be taking, for example, river is here. Okay, so river is here. Okay, so river flow is somewhere here. So what we have to do, we cannot construct, for example, here, okay, so thermal power plant. So we have to take some canal and we have to put the water here. Whenever we require more water, again we have to take some more water, okay. So this is water allocation for the thermal power plant, okay. So anyhow, if river is near to the thermal power plant, there is no problem. So that's what for the Yadadri plant recently. So water allocation only pending, okay. So that's why this many days they have waited for the notification, okay. So anyhow, so this water requirement is definitely here. Why water requirement is required? Because this condenser and cooling tower continuously changing this exhaust steam into so hot water, okay. For this only water required, and that water only we have to take into, so that water only we have to take into this boiler and conversion of the steam, okay. So this is the reason, okay. So the what they are asking, so pond requirement, okay. So otherwise the spray pond they have given here, okay. So spray pond, okay. The purpose of spray pond in thermal power plant is, okay, options, to deposit the ash coming out of the thermal power plant, okay. So they have given, so whatever ash is coming, okay, so from the boiler there will be bottom ash coming, okay. So bottom ash, so that we will be depositing in a different area, okay. So not here, okay. So we will not deposit in the river, because otherwise we will not deposit in this pond. Otherwise this water will be wasted, right? We cannot use that water again, okay. So that's why should not keep it there, okay. So next option, to cool the water coming out of condensate, okay. So this is the correct option directly, okay. So to cool the water coming out of condensate, okay. So near condenser will be hot, because so it's continuously changing the hot steam into hot water, okay, or exhaust steam into hot water. That's the answer, okay. So next question, which type of alternator is employed in thermal power plant, okay. So directly, so non-salient pole type. So if you are from electrical, okay, so you will be understanding this from the machine subject. So otherwise others, so just directly remember this one, no need of more explanation. It will take a lot of concepts into us, okay. So slowly one by one about this alternators we'll discuss in the machine subject, okay. So next question, the indication to determine the incomplete combustion is, okay. So the indication to determine incomplete combustion, okay. So where is this combustion happening? Combustion is happening, so in the boiler, okay. So combustion is happening in the boiler. How you will know whether it is properly combustion is happening or not properly combustion is happening, okay. How you will understand, that's what they are asking. What is the indication they are asking, okay. So anyhow, what are the outcomes? What are the outcomes of this boiler? So one is steam, another one is this ash. Yes or no? So one is this is steam, okay. So steam will be going like this, okay. So and another one is ash. In ash also two types are there. So one is bottom ash, another one is fly ash, which will be having this flue gases, okay. So either you need to examine what is the outcome of this one, that only we have to examine, okay. Then you will be getting, okay. So if you see the options here, what are there? High percentage of carbon dioxide content, okay. So in the flue gases, high percentage of CO content in the flue gases, high temperature of the flue gases, all of the above, okay. So definitely this flue gases already having high temperature, okay. So temperature cannot be controlled here. So based on flue gas percentage, okay. So based on the coal type also, so there will be flue gas temperatures will be depending, okay. So we cannot comment on this temperature whether they are having more temperature or low temperature like that, okay. So these two only we need to observe, okay. So what is the easy thing is processing of CO is easy, okay. So by understanding CO content, carbon monoxide, okay. So by understanding carbon monoxide, so we can understand, okay, so whether these are having a proper combustion or improper combustion, okay. See, the indication to determine the incomplete combustion, okay, that means the combustion is not happening properly, okay. There must be higher efficient, otherwise combustion process is not happening properly, okay. Next question, pipes carrying steam in thermal power plant are generally made of, okay. So pipes carrying steam, okay. So carrying steam, which pipes are carrying the steam? After the boiler, okay. So from this point, superheater, okay, through the superheater some pipes are going like this, right, okay. So these are having the steam, this is also having the steam, which is exhaust steam. This is nothing but a high pressure and high temperature steam, up to going to the turbine. Okay, so these pipes they are asking. Okay, so which material they are using, they are asking. So steel, cast iron, aluminum and cobalt. So directly remember this one. Okay, the material used here is steel material. Okay, so it will be easy for the steam. Okay, so steam transfer through the steel compared to cast iron, aluminum and cobalt. If you use the cast iron and aluminum, okay, so what will be happening with these three? So these can corrode or these need more maintenance also if you use these things. Okay, so compared to steel, so if you use these things, there must be more required. Okay, so otherwise you see even in the gas, wherever gases, otherwise wherever steam, otherwise wherever AC, okay, so any centralized AC, there will be steel. Okay, so we will be using the steel material. Okay, so for the flow of this steam, otherwise fog or any kind of this kind of materials. Okay, next question. Economizer of boiler has main function of economizer of boiler. Okay, economizer they are asking. So heat up the incoming water with excess steam, heat up the pulverized fuel by exhaust gases, heat up the incoming air by exhaust gases, heat up the incoming water by exhaust gases. So everything is similar. Okay, so all these four options are similar. So let's see, first we will see about economizer, where it is, so then we can decide. Okay, so where is economizer? Economizer is here. What is its work? Okay, it will take some water, and so that water has to come as hot water here. Okay, so hot water, how it is coming as hot water? Because flue gases will be flowing. Okay, so it will make the hot water by sending the flue gases onto it. Okay, so that's the answer. Okay, so economizer of boiler has main function of heat up the incoming water with excess steam. No, this is wrong. Okay, so with what? Not with excess steam. With what? Heat up the pulverized fuel by exhaust gases. No, heat up the incoming air by exhaust gases. Okay, so this is also wrong. Heat up the incoming air. Where it will be? It is in the air preheater. Okay, so next, heat up the incoming water by exhaust gases. Okay, so this is the correct option. So we have to heat up the incoming water, because what is this element? So economizer water. Remember this one. Okay, so economizer, okay, so water. Okay, so water incoming. Okay, so water inflow. Okay, so next, superheater. What is this superheater? These all things we have to remember. Okay, so superheater, where it is? So from the superheater, so after the boiler, so steam will be going. Okay, so in superheater, steam. Okay, so next, air preheater. Okay, so air preheater, what it will be doing? So inside this, air will be there. Okay, so in one water, in one steam, in one air, like this. Okay, so these three we have to remember. Okay, so from the schematic we can understand. Okay, so flue gases are flowing like this. Superheater, first steam. Okay, so then water, then air. Okay, so water and air will be coming as the inputs, and steam is going as the output for the boiler. Okay, so we have to remember these things. Okay, so next question. In a superheater, pressure rises and temperature drops. Temperature rises and pressure drops. Temperature rises and pressure remains unchanged. Pressure rises and temperature remains the same. Okay, superheater. Okay, so let's see the superheater now. Where is superheater? Okay, superheater is here. Okay, so let's consider superheater. Okay, so what is going in the superheater? So in superheater, what is going? In superheater, steam is going. Okay, so in superheater, steam is going. Okay, so and we are sending the flue gases, hot flue gases we are sending like this. Why? Because that steam temperature can be increased more. Okay, so temperature can be increased more. We have confirmed one thing, temperature will increase in the superheater. Okay, so that's what we have to confirm. Okay, so about this only they are asking. Okay, so steam temperature can be increased. What about pressure? Okay, so pressure we need to observe. So these options, pressure rises and temperature drops. Okay, so this is wrong answer. Okay, temperature rises and pressure drops. Temperature rises up to here, it is correct only. Pressure drops or not, we need to understand. Okay, so temperature rises and pressure remains unchanged. This might be correct answer also. Okay, so pressure rises and temperature remains the same. Temperature will not remains the same, it will be increased. Okay, so that's why these two options we have to eliminate. Okay, so in these two, what is the correct one? Again, if you see the schematic ones, okay, so to increase the pressure, what we are doing? So here two other elements we are using. Okay, so completely see, whenever some water, okay, so from the demineralized plant some water is coming and it will be mixed with the feed water. So whatever hot water is coming, these two will be mixed, and here we are sending a feed water pump. Okay, so from this one we'll be sending like this. See, what is the element here means feed water heater. Okay, so this feed water heater. Okay, so feed water heater. Okay, so feed water heater, inside this there will be two different chambers. Okay, so one is low pressure heater and another one is high pressure heater. Okay, so in order if it is, so in this one bottom, okay, so from the bottom first low pressure heater will be having, next high pressure heater will be having. Okay, so these two combinedly will be calling as a feed water heater. Okay, so this is the one. So what we are doing here actually, first we are heating this water at a low pressure, then pressure we are increasing and high pressure. Okay, so pressure we have already increased. This water whenever you are sending into this boiler, pressure we have already increased. Okay, so and the steam pressure we cannot control properly, that's why steam pressure should not be changed. Water pressure only we have to change. Okay, so water pressure it will be easy to control, but steam pressure, okay, so it will be difficult for the handling. So that's why, so in after having the steam, whenever steam is coming outside, the pressure should not be changed. Understanding? The pressure should not be changed. Okay, so that's why in superheater what is happening? Temperature rises and pressure will not be changing, or pressure will be unchanged. That is the answer for this question. Okay, see, temperature rises and pressure remains unchanged. Option C is the correct one. Okay, see, very important bits all these things. Okay, so definitely whatever 4 questions will be coming, 4 or 5 questions from the power plant engineering, from the thermal power plant, from this session only. Okay, so you will be definitely getting 1 or 2 questions. Okay, so next, as the size of thermal power plant increases, so the capital cost per kilowatt of installed capacity. Okay, so what it will be happening? Increases, decreases, remains the same, may increase and decrease. Okay, so we don't have any comment on this other one. So remaining we need to observe. Okay, so what is the consideration they have given? So size of the power plant. Okay, so the size of the thermal power plant increases. Size means, see, in terms of megawatt or kilowatt, no problem. Okay, so one power plant is 1 megawatt. Okay, so another power plant is, for example, recent one. Okay, so 800 megawatt. Okay, so these two are there. See, this is the generator capacity, right? How much it can be generated like that. Okay, see what is happening for this one: transportation charges, constructional charges, all these things. Okay, running charges, all these things will be so more for this one. Okay, but for this one, once you operate for 1 hour, what is happening? 1 megawatt hour energy is producing. Okay, so that means 1 hour if you generate, here 1 megawatt. Okay, 1 megawatt hour it is. Okay, here 800 megawatt hour is producing here. Okay, so energy. Okay, so that means where it will be easy, so here more energy is there, so then we can be so easily so manage the losses here. Okay, so that's what the analysis. So losses will be running cost. Okay, so we can easily call as running cost. Okay, so because losses are less, running cost is less here in the so higher power rating plant. Okay, so that's what the size of the thermal power plant. Okay, so size of the power plant means installed capacity only we have to consider. Okay, if the plant size is more, that means the generation capacity must be higher. Okay, so whenever it is happening like this, the running cost will be decreased. Then what is happening? The capital cost per kilowatt installed capacity, it will be decreased. Okay, so size increases, then the capital cost per kilowatt. That means whatever we have spent on this one, okay, whatever we have spent on this one for the construction of thermal power plant, so that cost will be decreased. Okay, so easily there will be more power generation is happening. That's why cost per kilowatt of installed capacity will be decreased. Okay, so that's for the analysis. Next, electrostatic precipitator is installed between, okay, so it's a simple question. Electrostatic precipitator, whenever you see this kind of questions, okay, this kind of question definitely will come. Before that electrostatic precipitator, okay, sorry that, okay, so before electrostatic precipitator, so there will be air preheater. Okay, so air preheater. After that what will be having, so there will be induced draught fan. Okay, so ID fan must be there. After that what will be having, the chimney. Okay, so from the chimney, so there will be smoke must go outside. Okay, so this is the order. Okay, what they have given, induced draught fan and chimney. Induced draught fan and chimney, nothing is there between. Okay, so air preheater and induced fan. Okay, air preheater and induced fan, correct. Okay, economizer and air preheater. After this what will be having, so there is a economizer. Okay, so economizer. So another one, so boiler, furnace and economizer. Okay, so boiler, furnace and economizer in between, so nothing is there. Okay, so after this boiler only here. Okay, so between this nothing is there. Okay, so this is the one. So anyway, answer for this question is B. Okay, next question, why reheating of steam is used? Why reheating of steam? Where we are using reheating? Reheating is a new word here, right? Okay, so let's see the diagram once. Okay, so where we are reheating, here steam is producing in the boiler and it is going in this way. We are heating in the superheater. Okay, we are heating in the superheater. Why we are reheating this? So reheating this steam in the superheater, that's what they are asking. Okay, so why we are reheating? Because whenever temperature rises, the work capacity of this turbine will be increased. Anyway, input we are not changing. Input is steam. Okay, so input is steam. That input steam we are not changing, like more steam will come, less steam will come, not like that. Steam already produced. Why we are increasing the temperature? That's what they are asking. Why we are increasing the temperature? To increase the work output. Okay, so only that. Efficiency will not be depends upon this one directly, because efficiency depends upon the input and output parameters only. Output parameters only. Okay, so to increase the turbine inlet temperature. Okay, so turbine inlet temperature directly, so we cannot comment on this one, because so the temperature, it is the temperature which is attained by the turbine at the nose of the turbine. Okay, so anyhow, so this does not related to this one directly. Okay, so to reduce the amount of fuel used. Okay, so fuel is our combustion steam. How it is steam is coming from the coal only. This steam is coming. Okay, so nothing related to this. Okay, option is B. Okay, the efficiency of chimney is approximately, chimney efficiency they are asking. So I don't want to give this question, but just want to tell. Okay, so whenever chimney is like this, here induced draught fan will be there. So whatever is coming, it should not throw this side. It should not throw this side. Understanding? So it has to throw towards the atmosphere, which should not come again like this. Okay, so but whatever we are using in our India at present, okay, so we are having very less efficiency as like this near to this. Okay, so that is the option. So now recently, so they have changed some of the norms. So recently in 2017 they have changed certain norms of electrostatic precipitator and induced draught fans. Okay, and chimney. Okay, so chimney, so these some of the norms they have changed. After that, so this efficiency little bit increased. Okay, for the chimney it is. Okay, anyway, electrostatic precipitator, it has to collect all these things. Okay, so next question, compounding of steam turbine is done for. Okay, so compounding they are asking. So why we are doing compounding means, so whenever one turbine is there, okay, so if this is the turbine, if a single turbine is there, it will be rotating with higher speeds. Okay, higher speeds. So what we will be doing, we will be combining, okay, or compounding. Okay, so combining. Okay, so 2 or 3. Okay, so 3 turbines. Okay, so 3 turbines majorly used. Okay, so combining 2 or 3, anything possible. So combining 3 turbines, so generally in the steam power plants only. Okay, so in steam power plants we'll be doing this. So to reduce the speed of the rotor. Okay, so the rotor speed. So after the turbine, so there will be some shaft, okay, coupling will be there. Okay, so mechanical coupling will be there. So then rotor, after that stator will be there. So this is the electrical output we are collecting through this wires. Okay, so to reduce the speed of this rotor, because so whenever this is a synchronous machine. Okay, so this is a synchronous machine, it has to maintain, okay, so it has to maintain the synchronism every time. So that's why to maintain this speed, and we need reduction of these speeds also. Okay, so because whenever you use only one, it might be going out of the reaches. Okay, so that's why, so for the better rotation of this rotor, better speed control of this rotor, we'll be doing the combining, okay, so or compounding of the steam turbine. Okay, so that's what we have to use, increase for the reducing the rotor speed. This is the correct one. Okay.